Today, we're going to talk about something that's at the very heart of modern software, how applications talk to each other. We're going to dive deep into the design principles behind powerful, predictable, and seriously scalable APIs using an architectural style you've probably heard of called REST. Let's jump right in. So think about it for a second. How do all the different apps on your phone just work together? How does your weather app get the forecast? How does your Maps app know where the traffic is? The magic behind all of this is a well-designed, well-thought-out interface. And that interface, well, that's your API, the application programming interface. The best way to think about an API as like the front door to your entire service. It's the official, public-facing set of rules that says, here's how you can talk to me, here's what you can ask for, and here's what you'll get back in return. Now, there are a bunch of ways to build that front door, but one of the most successful and, frankly, widespread philosophies out there is REST. That stands for Representational State Transfer. And this is super important. REST isn't a strict protocol. It's not a law you have to follow to the letter. It's more like an architectural style, a set of guiding principles that help you create systems that are flexible and built to last. Okay, so what does it actually mean for an API to be RESTful? Well, it all comes down to following a set of core ideas, or constraints. When you put them all together, these rules build the foundation for an API that's a joy to use, and just as importantly, easy to maintain. There are 6 of them, to be exact, and these aren't just arbitrary rules someone made up. When you apply them together, they create a system that's not only simple to get your head around, but one that is incredibly scalable and can handle things going wrong. This is all about building services that just keep working, even when you're throwing a ton of traffic at them. We're going to zoom in on the big 4 that really form the bedrock of any solid REST API. Now, these aren't steps in a process. Think of them more like ingredients that all work together. Separating the client and server, the absolutely critical concept of statelessness, making responses cacheable to speed things up, and the one that ties it all together, the uniform interface. First up, client-server architecture. This is a big one. It means the user interface, the client, the pretty stuff you see on the screen, is totally decoupled from the data storage, the server, the engine room in the back. The huge win here is that your front-end team can be building a slick new mobile app while the back-end team is busy optimizing the database, and they won't trip over each other. That separation lets you move way faster. All right, next is statelessness. And honestly, this one is a total game changer. It means every single request sent from a client to the server has to be a self-contained package. It's got to have every piece of information the server needs to do its job. The server, in return, has the memory of a goldfish. It keeps no memory of past requests. It treats every single one like it's the very first time. You might be thinking, hold on, why would you want your server to be so forgetful? Doesn't that sound inefficient? Well, this principle is actually the secret sauce for building massive, super reliable systems. It's what lets services like Netflix or Twitter handle millions of people at the same time without breaking a sweat. It all boils down to 2 huge words, scalability and reliability. Because any server can process any request without needing any backstory, you can just throw more servers at the problem to handle more traffic. That's what we call horizontal scalability. And if one of those servers just, poof, disappears, who cares? The next request just gets routed to a healthy one, and the user never even knew anything was wrong. There's no fragile session to try and recover. Okay, this next one, the uniform interface, is arguably the most important constraint of them all. It's really a set of 4 subrules that simplify the entire architecture and make the API predictable and consistent. This is what separates a good API from a truly great one. Now, a key part of this is a concept with let's say, an intimidating name, HTOS. It stands for Hypermedia as the engine of application state. But don't let the name scare you. All it really means is that when the API gives you a response, it doesn't just give you the data. It also gives you links for what you can do next. It lets you discover the API as you use it. Kind of like how you browse a website by clicking on links. Let's make this real. Look at this example JSON for a user. You get the ID and the name, sure, but check out that _links object. This is the magic. The client app doesn't need to have the URL pattern for a user's orders hard-coded into it. It can just look at this response, find the link with the name orders, and follow it. This means the server can change its URL structure later, and the client won't break. It's incredibly powerful. So we've got the core philosophy down. Now let's shift gears and get into the practical, day-to-day best practices that turn these ideas into an API that developers will actually love using. First things first, When you name your endpoints, your URIs, think about them as things, not actions. Use nouns. So you would never, ever have an endpoint called /getUserOrdersById/123. No, no, no. Instead, you have /users/123/orders. The URI identifies the resource, in this case, the orders that belong to user 123. The action comes from something else. And on that note, always, and I mean always, use plural nouns for collections of things. It should be users to represent all the users, not user. This one simple convention makes your API instantly predictable. A developer sees users, and they can probably guess that products and invoices exist too without even looking at the documentation. So if the URI is the noun, the HTTP method is the verb. We use the standard verbs that are already built into the web. Get to retrieve data, post to create a new resource, put to update an existing one, then delete to get rid of it. And notice that term idempotent? That's a key concept. It just means you can run the operation multiple times and you'll get the same result as running it just once. Deleting a user twice is the same as deleting them once. But posting twice? Well, that'll create two different users. A great API is a great communicator, and we don't need to invent our own secret language for success and failure. We just use standard HTTP status codes. Codes in the 200s mean everything went great, like 200 OK or 201 created. Codes in the 400s mean the client made a mistake, like a 404 not found, and 500s mean, oops, something broke on our end. It's a universal language everyone understands. Let's wrap up with two final, absolutely crucial practices. First, always, always plan for the future by versioning your API right in the URI. Putting /v1/ in there from day one is a lifesaver. It lets you release a /v2/ later with major changes without breaking all the old apps that depend on version 1. And second, just use JSON as your data format. It's easy for humans to read, easy for machines to parse, and it's the undisputed king of modern APIs. So when you boil it all down, what's the point? All these constraints, all these best practices, they all serve one single goal: to create APIs that are predictable, stable, and just plain easy for other developers to work with. It's about building a solid foundation that can grow and change over time without falling apart. So as you go to build your next service, I want you to keep these principles in mind. Ask yourself, how can separating my client and server, how can making my service stateless, how can having a truly uniform interface make my next project more robust, more scalable, and easier for everyone to use?